Hello everyone. We are very glad to have the opportunity to share the research findings of our team on Black Hat issue. Today, our talk is called X in the Media, Attacking Faster Charging Pairs and Electric Vehicles. First of all, please allow us to introduce ourselves briefly. I'm Wu Huiyu. I'm a senior security researcher at Tensorflow. Now I'm mainly focusing on AIoT security research. I'm also a bug hunter, winner of Gibbon 2015 and 2020. I'm also speaker of Black Hat DEF CON, Hacking Box, and POC. And the other is my teammate Liu Xian. He is also a senior security researcher at Tensorflow. Now he is focusing on mobile security and IoT security. He reported multiple vulnerabilities of Chrome and Android. He also was speaker of Black Hat USA, Hacking Box, XCOM, and CSS. And the Tensorflow team was founded by Tencent Security Platform Department in 2017. Now we are focusing on security research in the areas of AIoT and cloud visualization. We have reported more than 200 vulnerabilities to vendors such as Google, Apple, Microsoft, and Amazon. If you want to know more about our team's research, you can visit our blog. Let's move on to today's topic. Our talk is mainly divided into 4 parts. The first part, we will introduce the electric car charging technology and standards. The second part, we will analyze the attack surface of electric charging, and in the third part, we will introduce what is X in the media attack. And finally, we will introduce how we attack the plug and charge technology in the real world. As everyone knows, the rapid expansion of the electric car market has promoted the construction of charging infrastructure. The DC charging is the main charging technology in the future. It has higher charging power, and in order to convert the charging voltage and current, the electric vehicle and the charging station will communicate after being connected to complete the handshake. There are different charging standards in different countries. For example, all electric cars in China must support the GBT standard. Electric cars use CAN bus to communicate with the charging pairs. Where in most parts of Europe, the CCS standards are used, and electric cars and charging pairs use PLC to communicate. With the exception of Tesla, who has its own supercharger network all over the world, it uses a private communication protocol. Okay, next. In addition, we also want to talk about why we choose to study the electric charging security. The main reason is that we found the electric vehicle infrastructure is making progress towards a more intelligent and more high-power direction. But at the same time, the construction of the charging stations is accelerating all over the world, but there is little research on the security of electric vehicle infrastructure. So we want to try to research its security. In the following section, we will briefly analyze the attack surface of electric vehicle charging. First of all, electric vehicle charging pairs are also Internet of Things devices, which usually have built-in systems and operating interface. So it means its attack surface involves hardware, systems, cloud service, and communication. It's really traditional. But our focus is on the security of the communication protocol between the electric vehicle and the charging pair. There will be a new and interesting exploration. So the following picture shows the process of charging a car at a DC charging station. The charging controller communicates with the BMS before charging to confirm the charging voltage and current, which involves a lot of data exchange. So we think if we can implement a man-in-the-media attack, we may be able to find some vulnerabilities in BMS and charging control through fuzzing. Second, maybe we can analyze the private protocol and bypass identity authentication mechanism. Or we can damage the car by temporarily with the charging volt and current. Next, we will share the section about X in the media attack. First, we will talk about its architecture. Then we will talk about the challenges and the solutions we encountered in the testing process. And finally, we will share the quick test conclusions on Tesla's supercharger. In order to conduct security testing safely and conveniently, we have designed a tool called XCharger. The core of XCharger is a data processing terminal based on STM32 MCU and all the Raspberry Pi, which isolates CAN-bus message from BMS and charging pairs. All CAN-bus messages cannot be transmitted normally until they are transferred through XCharger, which allow us to monitor buzzing and temporary CAN-bus messages in the whole charging process. Another feature is that we designed the whole tool into a 20-inch suitcase, which has two charging sockets. One is connected to the charging pair, and the other end is connected to the electric vehicle. The high volt current is directly connected, and only 4 CAN-bus communication interfaces are exported to ensure the high voltage safety. Next, let's talk about why we do this and the challenges we face. When we do security research, we think the most important thing is should be able to ensure that personal safety and vehicle safety are not be threatened in the test. The DC charging can reach a voltage of up to 715 watts or a current of 120 amp. Once a short current occurs, is very dangerous for the tester and the car. Secondly, we hope that the attack equipment should be highly compatible, suitable for all electric vehicles with Chinese DC charging standard. Instead of requiring customization for each brand of electric cars or charging pairs, we also found CAN-bus communication requires no latency, and the man-in-the-middle attacks needs to ensure that frames will not be dropped. So all of 3 parties is all very important. And we rented a Tesla Model 3 for testing. And we found that is a charging port exported to the CAN-bus interface with a separate plug, which means that we may be able to disconnect the origin connection in the truck and to achieve a man-in-the-middle attack. But the problem is that it may need to land damage, so which doesn't seem suitable for such an operation on a rented vehicle. A perfect solution we have given is that the equipment shown below. As you can see that it has 2 charging sockets. One end is connected to the electric vehicle, and the other end is connected to the charging connector. The CAN-bus interface of BMS of the electric vehicle and the CAN-bus interface of the charging pair are all exported on the surface. At the same time, we have customized a dual plug charging cable to connect the equipment and the car. This equipment is designed by us and made by a professional vendor in Shenzhen, which can ensure the safety of high voltage power use. This equipment not cheap, but is very safety. And there are many open source tools available for CAN-bus, the mandatory, fuzzy, and temporary. To use both Raspberry Pi and two-way CAN extension boards, we can use Python to develop a testing framework and built-in Ubuntu system. Due to the some reason, We will release more details and code in the future. And after this, we can use XCharge to do something. So we use XCharge to do a quick test on the Tesla Supercharger in China. And the test results verified that the device can capture the message successfully. But we do not have any more tests because we do not have the GBC file to translate the CAN bus message. In conclusion, we found that some of the message in the CAN bus communication between Supercharger and the Tesla Model 3 use private protocols, and some message conform to the GBT standard. When testing with the Model 3, there is a high probability that it will not be able to charge successfully. The reason is still being analyzed. If you want to reverse the complete protocol, it may be a better choice to analyze the firmware of BMS or the supercharger. In addition to the Tesla supercharger, we spend more time in public charging station. And in the following section, we will share how to attack the plug and charge technology in public charging station in China. First, we will introduce in the principle of plug and charge and how to use XCharge tools to attack it to achieve free charging. Finally, we will briefly analyze the future trend of the charging technology. Plug and charge is a new way of automating payment for electric vehicle charging. Users do not need to swipe their cards or scan codes. Just connect the charging pair to the vehicle charging port to automatically complete the identity authentication and payment. For electric vehicle companies that build their own charging pairs, such as Tesla, private communication and authentication protocol can be used to ensure the security of plug and charge. But considering the compatibility and the cost, some public charging station operators have chosen to use VIN number to complete vehicle identity authentication on the basic of GBT standard. We think operators do not realize the VIN number is not a security identification in secure CAN bus communication. The GBT is the Chinese standard for electric vehicle battery charging. Cable charging standard GBT is based on SAE G1939 network protocol and uses the CAN bus with a point-to-point connection between the charger and the battery management system. The transmission rate of 215 kbits per second is used by default. Charging communication involves both the battery management system and the charging agree on the power requirement of vehicle and both the amperages and water rages used during the charging, as well as monitor the charging process. With GBT protocol, communication is divided into following part during the charging process. It divided into 6 parts. In the handshake recognition part, the charger connection check is completed and general information such as protocol version and vehicle information is exchanged, such as battery type, VIN number, and so on. What we most concerned is about that during the handshake identification process of part 2, the BMS will transmit the VIN number to the charging pair. After actual testing, we use contours and the DBC file to successfully translate all messages during the charging process. We found the BMS of electric vehicle transmitted the vehicle's VIN number to the charging pair for identity authentication in BRM message during the handshake recognition. So the following is the completed plugging and charging the architecture. First, the car owner needs to register and find the vehicle's VIN number on the charging pair operator's application and activate automatic payment. Secondly, when the car owner is charging, he only needs to directly plug and charging gun into the electric car to charge. The charge pair will upload the VIN transmitted from to the BMS to operator's cloud server. And the operator will query and return the user credentials to the VIN in the background database. After the charging pair receives the user's credentials, it will start charging and automatically pay at the end of the charge. VIN number is a unique code including a 3 number used by automotive industry to identity individual vehicles. The biggest problem is VIN number is a public plain text information with specific coding rules, and it can also be obtained from the front windshield of the car. In order to configure the attack script quickly, we have written a tool that its main function includes the tempering of VIN number, charging voltage, and current. And it also supports the BMS simulation. It's very interesting, so that we can test the charging pair without a vehicle. It will save many time. In order to verify our tool in the real world, we rented 5 electric cars of different models and tested multiple charging stations that support plug and charge. We verified that after obtaining the VIN number on the window sheet of the vehicle, the charging pair can be successfully attacked by X-Charger to achieve the free charging. And for now, all the vulnerability we found have been notified to the vendor and fixed. Okay, my part is over. The following time will be shared by my teammate Liu Yuxia.
Thanks. I will continue to share the following part. In this part, I will introduce some of the latest charging standards. According to the news, the next generation charging standard, Chaoji, dominated by China and Japan, will be officially released. It is improving the security of communications and identity authentication. Chaoji charging support plugs and charge, V2X, automatic charging systems and other new technology application. Some of the security risks mentioned in our talks may be resolved. In addition, we also see another new standard, ISO 15118 is a standard for vehicle-to-grid communication. Use asymmetric encryptions and digital signatures to ensure the security of communication between electronic cars and charging stations, and supports plugs and charge. It uses PLC communication, which is mainly used in rural. Through the discussions of these trends, we are very happy to see that security has become a must be considered in these standards. We believe that in the near future, when these new technologies and new standards are applied in the real world, they will promote the security development of the entire electronic vehicle charging industries. Okay, that's all. Thanks for your listening. And if you have any questions, you can connect us by this mail.